We're going to go ahead and start. Take your index card. We're going to go ahead and start and create a little cheat sheet, another cheat sheet. So in your index card, we're going to write down consecutive integers. And my B3 did this yesterday. What were the consecutive integers? X, X plus 1, and then X plus 2, and so on, right? Because they're consecutive. So if this is 1, you add a 1 to get a 2. You add a 2 to get a 3. You add a 3 to get a 4, because your first one is always 1. All right? Now, consecutive odd or even. Consecutive even or odd, if the first one is x, the second one would be what? X plus 2. And then the next one would be x plus 4, and so on. Okay? So we're going to need this for the couple of worksheets that we're going to be working on in just a second. Okay, so keep that and keep your factoring, right? This one, the plus, plus, minus, whatever, all those little rules, that cheat sheet that we have with all those. Are we good? Yay? All right, so let's start with the first one. All right, so for number 1, 8 more than the square of a number is the same as 6 times the number. So let's start over here. You have your backward words. That will be then. And that's your equal sign. Okay? So what's the square of a number? X squared. You don't know the number, but you do know that it's squared. If you don't know the number, it's always x. More than means what? Plus, and then you're adding 8. And that is the same as 6 times the number. 6x. Very good. And now to solve, we got to move everything to the same side, correct? So I'm moving this to the other side. And I'm going to go ahead and put them in order, right? So x squared minus 6x plus 8 equals 0. And then I can factor this too, right? Thank you. Alright, so what multiplies to positive 8 and adds up to negative 4? Negative 6, I'm sorry. So negative 4 and negative 2, right? Which means what are my two solutions? X equals? 4. And x equals? 2. So the number could be 4, or it also could be 2. Yay? Alright, number 2. $15 less than, backward word, and then is, right? The square of a number, x squared. Less than means minus, and then how much are you taking? 15, and that is the same as twice the number, 2x. All right. So that would be, move that 2x to the other side, right? Forgot to box those. So that would be x squared minus 2x minus 15 equals 0. Minus minus. Okay, so plus minus, which means I'm going to subtract, right? Needs to multiply to negative 15, add up to negative 2. Negative 5 and positive 3, right? Negative 5 times 3 is negative 15. And negative 5 plus 3 is negative 2, right? So x equals what? 5. And x equals? Now these are numbers, so it could be either one. Remember, it cannot be negative when it's talking about length or when it's talking about time, right? But otherwise, yes, these are numbers. Yes, numbers can be negative, correct? All right, so it could be 5 or negative 3. Are you with me? Yes? All right, let's go to number 3. What should we just should highlight that the result is 6, okay? Because we don't have any backward words over here. So if a number is added to twice its squared. Okay, so a number is added, so x plus twice its squared. 2x squared. The result would be 6. Yay? Alright, so now I got to move that 6 to the other side, right? So that would be x, 2x squared plus x plus 6 equals, I'm sorry. Okay, I'm going to start all over again because obviously I need more coffee. So it was x plus 2x squared equals 6. Now we're moving, and I got to put in order, right? Okay, now I think I got it. Are we good? Shall we? All right, so let's see. Plus minus would be what? Okay, so I'm subtracting, right? I got 2. It's just 2 times 1, so might as well just go ahead and put them over here. But 6 could be 6 and 1 and 2 and 3. So how can I factor this? It needs to be positive 1. 2 and 1? Is it going to be 6 and 1? No, because 6 times 1 is 6. You take away 2. That's not going to be 1. 6 and 1 is, or even if you do it this way, so it's definitely not going to be 6 and 1. So I can eliminate 6 and 1. So how can I get 1 over here? This is really easy. 2 and 2, right? That would be 4. 3 and 1 would be 3. And if I take away that 3, I get a positive 1, which means that 3 needs to be negative, and it needs to be multiplied by the 1. So where does the 3 go? First parentheses or second parentheses? First. So minus 3. And then the 2 needs to be on the other parentheses so that I can have that 2 times 2. Yay? Alright, so what do I get over here? 3 halves, right? Plus 3, divide by 2. And then x equals negative 2. So these are numbers, so both of them are fair game. Yay? Alrighty. And you can check because your answer should be at the bottom, right? Should be at the bottom of the page. Let's double check. Do we have 4 and 2? I don't see it. There it is. That was number 1, right? 5 and negative 3? I can see it. Thank you. That's number 2. Then we had 3 halves and negative 2. There you go. T. Yay? Alright, let's go to number 4. Alright, I'm going to highlight my backward word and then my equal sign. Usually if I do that, that's enough for me, but if you need to highlight a little bit more, you go right ahead and you highlight a little bit more, okay? Alright, backward word. 4 times the square of a number. 4 times the square of a number. Very good. Less than means what? Take away 7, and that's equal to 18. We got to move that 18 to the other side. So 4x squared minus 7 minus 18. Yay? Alright, negative 7 and negative 18. Very good. Alright, so how do I factor this? Look at it. Plus 25? What do you mean plus 25? So it's a binomial, yes, but how do I factor it? Say that again, Dora. Differences of squares. Very good. That's a differences of squares, right? And we got a perfect square root over here and a perfect square root over here. So we're going to have the same parentheses, 1 plus and 1 minus. There you go. And square root of 4x squared would be 2x. And then of 25 would be 5, right? All right. So it's the same number, but one positive and one negative. So this one would be minus 5 divided by 2. And this one is plus 5 divided by 2. Yay? All right, can you see that down there? Yep, there it is. Whoop, there it is. Right here. Oh. Yay? Yes? Yes, we got this. All right, number 5. 2 consecutive integers. All right, so go to your cheat sheet. What are my consecutive integers? X, I need 2. So I need x, and I also need x plus 1. Very good. Whose product? What does product mean? All right, so I'm going to multiply x and x plus 1, and that should be equal to 56. Yay? Everybody with me? All right, I'm teaching very slow today. What's up with that? X times x squared, and x times 1, x, and then I'm going to have to go ahead and move that 56 to the other side. Can I do that all in one step? And say minus 56? Yay? Yes?
Just a friendly reminder, teachers, do not use your computers for attendance. Do not use your computers for attendance. Attendance today is manual.
All right, are we good? All right, so plus minus would be what? Okay, so we're subtracting, right? Multiply to negative 56, add up to 1. That's really easy. 8 and 7, right? And which one needs to be positive, the 8 or the 7? So plus 8 minus 7. So what are my two solutions? Negative 8 and x equals positive 7. There you go. All right, so negative 8 and positive 7. Do we have it down there? I don't see it. The last one. Or that one. Positive 8 and negative. Ooh. I don't think so. Yeah, you can switch them around too. If you switch them around, you could probably get that 56 over here too. Not sure. I don't think we did it wrong. Let me go back to it. 2 consecutive integers, so that will be x and x plus 1. Are we there? Are we correct so far? All right, whose product? We're multiplying is 56, right? X times x is x squared, x times 1 is x, and then minus 56. I think we're good. I think we're good. Okay. And if we switch to positive 8, oh, and positive 8 and positive 7, it's also 56. There you go. You got it. Yeah. Oh, my God. Brain fart. Yeah, so that was number 5. Because negative 8 and negative 7 is 56, but positive 7 and positive 8 is also 56, like Alvin just pointed out for us. All right? So let's go to number 6. Find 2 consecutive positive odd. Very good. So if they're odd, it would be x and then x plus 2. And whose product, so we're multiplying them, equals 35. Yay? We're going to move on to something hard. X times x squared, x times 2, 2x, and then minus 35 equals 0. Is this too much or can we handle it? We can? We're good? Alright, so I'm definitely subtracting, right? So that I can get that negative. It needs to be equal to negative 35 and equal to positive 7. I'm sorry. I just told you. Positive 2, it would be plus 7. And then minus 5. When you multiply it is negative 35. When you subtract is positive 2, right? So x equals what? Negative 7 or positive 5. And then again, I think this is going to be the same thing, right? They could be both negatives or both positive. Yay? Or actually, look, the only option that we have over here is 5 and 7. The only option we have is positive 7 and positive 5. We don't have one that has both of them, right? Nope, I don't see it. All right, 7. 7 and 8, and then 9 and 10, you're not scratching them out. We're using them for something else. 7, the sum of the squares of two consecutive integers. Okay, so if they're consecutive, one needs to be x, the other one needs to be x plus 1. It's the sum of their squares. The sum of their squares. I'm definitely adding, but what am I adding? The sum of their squares. Tell me what to write. Okay, it's a sum, so I already got my plus, right? Of those two integers squares.
Oh, you make them squares?
Thank you. So I'm going to change it to what? To x squared, and I'm going to change that to x plus 1 squared, because it's their squares. Yay? All right, now x squared is just x times x, right? Which would be x squared. You can make a box out of that one. I'm not sure if anybody has already figured out the pattern when it's squared. Let's just do the box. It's okay. I'm going to do the box over here. So this is x squared, x, and then 1, right? So what do I get out of here? X squared plus 2x, 1, 2, plus 1. And then what does it say it's equal to? It's equal to 41. So the sum of the squares of two consecutive integers is 41. Okay, so we're good. Yes, we do. So these two are going to be 2x squared plus 2x plus 1 minus 41. Correct? So that would be 2x squared plus 2x minus 40? What? Yes? I'm sorry. I thought I messed up. All right. Now we need to factor. How do we factor? This happens every year. We always forget the first darn step. Thank you. Because nobody said it. Nobody told me GCF, right? We forget. You cannot forget. You can factor this the way that it is, but it's going to be a lot harder than if you don't have that 2 in front of that x squared. So do that darn GCF. All right? GCF is 2. That would be x squared plus x minus 20. Now that's a lot easier to factor than 2x squared plus 2x minus 40. What? And then the plus 1, that would be 40. Right? Yay? Alright. So it's going to be plus minus because that's the only way to get a negative, right? But it needs to add up to positive 1. What two numbers multiply 20? Alright, so plus 5 minus 4. When you multiply, that would be what? Negative 20. When you subtract, that would be positive 1. Yay? Alright, so what are my solutions? X equals what? Negative 5 and x equals 4. Yay? Are we good? Alright, one more, number 8. Find two consecutive odd. Okay, so if they're odd, it would be x and x plus 2. So one of them is x, the other one is x plus. Yay? Now remember in here, let's go back to number 7. Remember in here that we have to plug in those numbers, right? We have to plug in the negative 5. I'm not doing it, but we have to plug in the negative 5 and the 4. And those are the actual numbers, right? Yay? So we're going to have two options. One with a negative 5 and one with a positive 4. That's why we got that over there on number 5, right? Yes? Yay? I think we did this a little bit yesterday. Are you with me? Because I forgot to do that because I was just assuming that you would remember, but we probably need to go in and start plugging in. I'm sorry about that. That was my fault. All right. Two consecutive odd integers such that the square of the first, so what's the first one? X, and it would be squared, added to 3 times the second. Three is equal to what? 24. Yay? All right. So let's do it again. Two consecutive odd, that would be x and x plus 2, right? Such that the square of the first, so it would be x squared, added to 3 times the second, equals, yeah, we got it, right? Okay, so now we have to distribute and move that 24 to the other side, right? So x squared plus 3 times x would be 3x. 3 times 2, and then minus 24. Very good, baby. So x squared plus 3x. What's 6 minus 24? Negative 18. Very good. And then that has to be plus minus because it's the only way that I'm going to get a negative 18, right? Negative 6 and or positive 6. Positive 6 and a negative 3. When you multiply, that's negative 18, correct? And when you subtract, that's positive 3, right? So x equals negative 6 and x equals 3. Okay, so this is what I mean by plugging in. Okay, these are your solutions, which are your zeros, correct? We saw that yesterday, that they were the zeros of the function. Yay? All right, so now we got to plug them in, right? So it could be negative 6. Negative 6 plus 2 would be negative 4. So that's a combination, right? Or it could be 3 and 3 plus 5 plus 2. I just told you. 5. So it could be negative 6 and negative 4 or 3 and 5. Yay? Now, but these are odd integers. Is that correct? What has the problem said? Odd. Right? So, did we really needed to substitute negative 6? No. So what are really truly my numbers? 3 and 5. Yay? Yes? Are we sure? Alrighty. Because we didn't do that on the other ones. Maybe we need to go back and do that. No? Do we got it or not? Alright. Here. Hold on, I'll show you in a minute which one I want to do right now. Oh, darn it. This one, babies. I don't know what order do you guys have it on over there. This one right here. I feel like I need to go back and plug in those numbers. I don't know why. Where's number 7? Hold on. No, 2 consecutive. We're good. Number 6. Oh, look. Let's go back to 6 and read the problem. This is why it was positive 5 and positive 7. I'm talking. Because number 6, look at what number 6, read number 6 for me again on the problem that, on the worksheet that we were at. Positive integers, right? So you cannot do -7. It has to be 5 and 7. That's why we couldn't see the -5 and the -7. Okay? So make sure, because this is a very, I mean, I even made it. I didn't even go back and check. This is a very common error. Picking the negatives when it says they have to be positive, or picking the positive when it says it has to be negative, or picking the odd when it says it has to be even. Okay? Or even when it says it has to be odd. So we got to be careful with that, okay? All right, so let's do 1, 2, 3, 4. We're going to do A through E, and then we're going to play a game. Do we want to do B2 against B3? No. Some people say no, 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 no. The problem is we don't have families in here completed. Like complete families. That's the only family. Yeah. No, your 100% participation, no. Yeah, we need to, yeah, I need to give you some points because everybody's here from your family. Why not? They got here. Everybody had the chance to be here. All right. Hey, whatever. The length of a rectangle is 3 centimeters more than the width. So it's talking about length and width. Who do you have info for? The length or the width? The length, which means your width would be x. All right, you got a backward word. Very good. What comes after that backward word? The width, which is x. If it's more than, you're going to add. And how many are you adding? 3. So the area of that rectangle is 70. How do you calculate the area of a rectangle? Length times width. Very good. So I'm going to take the x. I'm going to multiply that by x plus 3. And that equals 70. Okay. Does anybody have a teacher that is here right now? Okay. Ms. Mosia is not here. Who else? That's fine. You can stay here. All right. Who else? What? Not all everybody's going to Miss Mosia because I got 2 different classes over here. So where are you guys going? The rest of the class, the other B3. Oh, you come to me. All right. Go ahead and solve that while I tell the stuff that you do. Nice. All right, shh. Let's go. All right, so this would be x squared plus 3x minus 70, right? Because I got to move that 70 to the other side. All right, and then this one's really easy. You got to be plus minus, and it plus 10 minus 7, right? All right, so when you multiply it is negative 70. When you subtract is positive 3. Okay? So x equals, and x equals. Okay, now this is where we have to stop. This is talking about length and width. Can we really take negative 7? No. So the only one that we can actually pick would be what? 7. So this is 7, and this is 10. Look. What happens to the solutions and what happens to over here? It's the same numbers. It's just that both of them have to be what? Positive. Both of them have to be positive because it's talking about length and width, right? And length and width are never negative. Yay? All right, let's do B. The length of a rectangle is 4 centimeters more than the width. So you have info about the length, but you don't have info about the width. All right, backward word. After than comes with. So that would be what? X. If it's more than, what are you doing? Adding. How much are you adding? 4. And the area is what? 96. Yay? How do you calculate the area of a rectangle? Length times width. So this would be x times x plus 4 equals 96. Let's distribute. X squared, 4x, and then I'm going to go ahead and move that 96. Yay? All right. So there's no GCF, darn it. Okay. Because that 96 is a big number. And it's got to add 4. So let's start looking for factors of 96. 12 and 8? 12 times 8, 96? Yes. Yeah, but 24 and 4 will not give me a subtraction of 4, right? So they need to be numbers that are close together. They need to be numbers that are close together so that I can get a 4. And I think that if I subtract them, that should be okay, right? So the x should be, the 12 should be positive, and the 8 should be negative. When you multiply it as negative 96, when you subtract it would be positive 4. Yay? All right, so x equals negative 12, and x equals 8, but this is length. It's both numbers. They just both have to be what? So this is 8, and then 8 plus 4 is still 12, but it cannot be that negative 12, right? Yay? Pretty easy, right? Yeah, we haven't gone to the hard ones now. The length of a photograph is 1 centimeter less than twice the width, so the width is x. Backward word is then. Twice the width. After then. Twice the width. Thank you. Less than means minus, and how much am I taking? 1 out. Okay, so the area is 45. All right, so x times 2x minus 1 equals 45. With me?
Yeah.
All right, so x times 2x,
2x squared.
x times negative 1, negative x, and then minus 45 should be equal to 0. There's no GCF, so I'm going to have to factor this, right? With that, I really try to GCF so that I don't have that 2 in front of that x squared, right? Because it's a little harder. All right, so 2 is just 2 times 1, but 45 is 45 times 1, and 9 times, oh, why did I put 4? Woo! No, according to Miss Marina, it's 9 times 4. Get it right. Oh my God, yes she does. So 9 times 5. 15 times 3. I like to write them all. Wait. Before you do that, just make sure that you write them all, okay? You try as many as you can. It's definitely not going to be 41 because I need a 1, right? Now, if I do 2 times 5, that's 10, right? And if I take away a 9, that will be 1, right? But I need that 10 to be negative, which means the 5 needs to be negative, right? So 2x and x. The 5 and the 2 need to be multiplied, so same parentheses or different parentheses. So minus 5. And then the 9 needs to be in the different parentheses as that 1. Okay, so x equals what? Negative 9 divided by 2. And x equals? Alright, now this is... Yes. Alright, so this is 5. See, in that case, it's not going to be that negative 9.5. Because 2 times 5 is 10, right? Minus 1. So it's a 9 by 5. And then 5 times 9 is 45, right? Yay? Alright, I need you to do D on your own. Go. I mean, not on your own, as a group. Go. D as a group. Alright, are we good? Are we good, babies? Alright, let's go to D. If the sides of a square increase by 3, the area becomes 64. I highly encourage you to make pictures because it's hard to see, okay? So, I'm going to make a square. Do you know the sides of that square? Do you know the sides? No, you don't. But you do know that all the sides on a square are what? Alright, so it doesn't matter what this side is, it's going to be exactly like that one, right? Now those sides are increased to create a bigger square, right? So that will be x plus 3. Yay? And then the area becomes 64, right? Yay? So this would be x plus 3 squared, which is x plus 3 times x plus 3, right? And that equals 64. Then you do a box for this, right? Yay? Did everybody have a chance to do the box? No? You should have gotten that from the box. Am I correct? And then minus 64 equals 0? Yes? All right, so what's 9 minus 64? 55? Negative 55? That sounds about right, and then this is really easy to factor. Has to multiply, it has to be plus and minus. That's the only way that I'm going to get a negative. Different signs, right? Plus 11 minus 5. There you go. So what are my two solutions? Negative 11. Are we going to pick a negative 11? No, because lengths are never negative. And then x equals 5. Stop talking. All right, so what is it asking me to do? Find the length of a side of the original square. Well, the original square was 5. What area did it have? 25. Thank you. It had an area of 25. Yay? All right, E, go. As a group, go. Stop playing around over there. Are we done? Then we really should not be playing around. All right, let's start. All right, so a square field has 5 centimeters added to its length and 2 meters to its width, okay? So special about a square, all sides are equal. You don't know what the sides are, but it's okay because they could both be x because it's the same. So the length is increased by 5, right? And the width is increased by 2. The new area is 130. And you got to figure out the x, which would be the original sides of the original square. All right? Of the square field. All right, so this would be x plus 5 times x plus 2 equals 130. Okay? And now we're going to do a box for this, right? So x squared, 2x, 5x, and 10. Okay? So x squared plus 7x plus 10 minus 130. I went ahead and I moved the 130. Yay? Alright, so this is x squared plus 7x minus 120 equals 0. And now we got a factor because there's no GCF. Alright, it's got to multiply to 120 and it's got to add up to 7, which means that the biggest number needs to be positive, right? Because I'm going to subtract. The only way to get a negative over here is that if I have different signs. So, oh my God, 120 has too many. But I do know that there need to be numbers that are close together. It cannot be 120 and 1, right? 12 times 10. But that doesn't subtract to 7. I can't hear. 3 times what? 3 times 40 does not subtract to 7. 15 times? Thank you, Ernesto. 15 times 8. You can start naming all the ones that you want, but there's only one of them that is going to have that subtraction. And therefore, it cannot be 120 times 1. It cannot be 60 times 2. It cannot be 40 times 3. It cannot be 20 times 6. Those are too big. When you subtract, you're never going to get that 7. So it would be 15 and 8. The 15 needs to be positive. The 8 needs to be negative. So that 7 keeps its positive, right? So x plus 15 and x minus 8. So what are my two solutions? X equals negative 15. X equals 8. Now this is length. So we're not picking that negative 15. Very good. So the original had side lengths of 8. On the test, I might go even further and say, what's the area of the original? 64. On the test, I'm not asking you for X, I'm asking you for 64. All right? So you can take it up a notch and do one more step. Are we good? Yay? All right. Let's take a break.